In this video, we will see what is thrashing, what are the causes of thrashing, and how to recover from thrashing. At any given time, only a few pages of any process are in the main memory, and therefore more processes can be maintained in memory. Furthermore, time is saved because unused pages are not swapped in and out of memory. However, the operating system must be clever about how it manages this scheme. In the steady state, practically all of the main memory will be occupied with process pages so that the processor and the operating system have direct access to as many processes as possible. Thus, when the operating system brings one page in, it must throw another page out. If it throws out a page just before it is used, then it will just have to get that page again almost immediately. Too much of this leads to a condition called thrashing. The system spends more of its time swapping pages rather than executing instructions. So, a good page replacement algorithm is required. Here in this diagram, we can see the initial degree of multiprogramming up to some extents of point lambda. The CPU utilization is very high and the system resources are utilized 100%. But if we further increase the degree of multiprogramming, then the CPU utilization will drastically fall down and the system will spend more time only on the page replacement, and the time is taken to complete the execution of the process will increase. This situation in the system is called thrashing. So in general, the system doing more page replacement rather than executing instructions. So what are the causes of thrashing? The first one here is high degree of multiprogramming. If the number of processes keeps on increasing in the memory, then the number of frames allocated to each process will be decreased. So fewer frames will be available for each process. Due to this, a page fault will occur more frequently and more CPU time will be wasted in just swapping in and out of pages, and the utilization will keep on decreasing. For example, the number of free frames available here is 400. Number of free frames available 400. For example, we'll take that number of processes is 100. So we have 400 frames and the number of process is equal to 100. Then each process will get 4 frames. Here each process will get 4 frames. In case 2, if we take number of processes is equal to 400, here number of frames available is equal to 400 and the number of processes is equal to 400, then each process will get at only 1 frame. Case 2, this case is a condition of thrashing as the number of processes is increased, frames per process also are decreased. Hence, CPU time will be consumed in just swapping pages. Second problem here is lack of frames. If a process has fewer frames, then fewer pages of that process will be able to reside in primary memory, and hence more frequent swapping in and out will be required. This may lead to thrashing. Hence, sufficient amount of frames must be allocated to each process in order to prevent thrashing. So what are the recovery methods of thrashing? Do not allow the system to go into thrashing by instructing the long-term scheduler not to bring the processes into memory after the threshold. If the system is already thrashing, then instruct the mid-term scheduler to suspend some of the processes so that we can recover the system from thrashing. In the next video, we will see page replacement algorithms.